And our next speaker, of course, is Justin Stephen with the most puntastic con talk title, The IDEs of March. The Ides of March, you get it? Software is eating the world, and in the era of DevOps, those who are cutting the code often have privileged access to production systems and software delivery pipelines. A developer's workstation is a fantastic place for an adversary to be in 2019. We're often hearing about supply chain stuff, so yes, absolutely. We're relentlessly and rightfully focused on secure design, code quality, and killing bugs. But are we hearing the call to protect the people and systems responsible for building and operating our squeaky clean code? I see what you did there, because, you know, it's not, is it, really? Anyway, without further delay, Justin Stephen.
Fantastic, everyone can hear me? Cool. Thanks very much, Pat. My name's Justin. Really excited, as much as someone can be excited to talk about software delivery and software development, software security today, to share some thoughts, opinions, feelings I have about the security of tools and software used in developing software. So I'm a freelance application security specialist. In my spare time, I enjoy playing CTFs, attempting to write exploits, and long walks on the beach. From time to time, I stream on Twitch TV, where I do CTF challenges, vulnerability stuff, exploit stuff live, and make a fool of myself on the spot. Really important to note, I am not a developer, nor am I a pen tester. I've got some feelings and thoughts about both those disciplines, about how developers use their tools, and about how secure those tools are when they're used in the way they are, but I'm not a developer, so apologies for any misinformation I spread in that way, but these are just my observations as someone who does source code review and application penetration testing. I'm also not a pen tester, so while I test software, I don't do the business of hacking to businesses. I do have some thoughts and feelings about the risks that software development, software insecurities pose to enterprise, but I'm not someone who's responsible for doing the business to businesses. So again, apologies if I am not quite on the mark there. These are just my thoughts. So this is me. This is how I imagine myself as being Sid from Toy Story. In as much as when I'm bored, I tend to blow up my own toys. I look at the tools in my pipeline and the tools that I use in my work and think about, if I was to hack myself, what sort of bugs are there in the tools that I use? And if you're looking to get started in vulnerability discovery and bug hunting and exploit development, I'd really encourage you to start with what you know, start with the tools in your tool chain, or start with the software relevant to your industry. You've got the home field advantage there, you know a bit about what's going on, and it gives you some really interesting insight into the risks that you might be exposing your machine to with the tools you use. So what are we going to cover today? We'll start off with, what do I mean when I say software development software? We'll move on to some thoughts I have about why the people who use these tools are particularly interesting targets. We'll unwrap the layers on a couple of vulnerabilities I found a few years ago now in RVM and Visual Studio Code. And we'll close with some thoughts on, is this a risk? And if it's a risk, what sort of things can we do about it? So to start off with, what do I mean when I say software development software? I'm talking about the tools, applications, and programs used by developers on their workstation, used in build pipelines, things like your Jenkins and your Bamboo, all the little bits and pieces that fit into that software delivery pipeline. I'm talking about the tools that many of us as security... Actually, you know what? I'm curious. Who here is a developer? Cool. I'd say about 15, 20%. That's awesome. These are tools that apply to software development, but they also apply to many in kind of the pen testing or security hobbyist space as well. A lot of these tools are ones that many of us in the room use. So I'm talking, and when I think of software development software, I kind of split it into three different buckets, very, very roughly. So the left-hand slice here is bits and pieces, and these are the environment tools. They're things in your development environment and things in the build environment. They're helper tools or they're task runner tools. They're kind of the bits and bobs that help you get things done when you're developing and delivering software. The middle slice there is kind of the meat and potatoes of a software developer's workstation. It's your IDE, or your integrated development environment. It's a fancy text editor, changed my mind, but it's a fancy text editor with Features like syntax highlighting, a tree view so you can see all the files in the project, global find and replace, refactoring tools, little hover over tips. It has integration with tools in the first slice here. It's got integration with a compiler, a debugger, all these things that make life easy when you're cutting code. And finally, I put the rest of the tools in the third bucket of your build orchestrator. And these typically run on a centralized server. It's your Jenkins, it's your Bamboo, and these orchestrate the build and test of software in an enterprise. So for those non-developers in the room, this is very, very roughly what software delivery in an enterprise looks like. You've got your develop workstation up the top. They push code into Git. Jenkins or Bamboo or your build orchestrator pulls the code from Git, compiles it, runs all the tests. If the tests pass, it stores the build in an artifact repository, and sometimes it pushes it straight into production or test infrastructure. Also of note is the cheeky little channel I've put on the right-hand side there. These days, and we'll talk about this in a minute, many developers have privileged access to infrastructure. So today, I wanted to talk about this whole story, but that's a lot, I found out. So we're going to focus just today on the developer's workstation and the tools that are used on that development workstation as part of delivering software. So this is a flow that many in the room are probably quite familiar with, where we pull code down off of GitHub to look at it and or run it. So this is just an example, me putting those tools into a security person's workflow, because I'm sure many of us in the room have done this. And we're all quite aware that when you run random stuff off GitHub, if there's malicious stuff in the code itself, bad things might happen to your machine. But what about the rest of the chain? How many things in this git clone, cd, read the code, build the code, run the code, how many of these actually expose us to danger? Well, when you run a build, such as running make or bundle install to go and get the third-party gems against something you've downloaded off GitHub, it's surprising what goes on under the hood if you're not aware. A make file is really just a really, really fancy shell script. So if you run make, it can just run whatever it wants on your machine. So maybe the build metadata or the build manifest might be what gets you owned. What about reading the code? Well, surprise, surprise, when you view documents in a document editor, sometimes bad things might happen. So there might be vulnerabilities in your IDE, such that just opening the code with no intention to build it and run it might be what gets you owned. And we'll dig into one of these in a few minutes. So what about CD? So you download some code and CD into it. Pretty safe. Well, some of these helper tools that I mentioned before, they actually stitch themselves up into your shell and interfere or hook CD. And CDing into a directory with a malicious file in it might cause some harm, and we'll dig into one of these as well. And finally, git clone. Well, there's been vulnerabilities in Git itself, so even just pulling stuff down off GitHub, if it's a malicious repository, Git can stumble and end up getting you owned. So it's kind of surprising when you look closely at the tools that go into this 5-step process, just how much attack surface there is under the hood in these tools we use. So why? Why would we want to attack people who run these types of tools? The first thing that comes to mind for me is confidentiality of enterprise source code. So source code for an organization is often very valuable intellectual property, and if it's leaked or stolen, it could be stolen for economic espionage, or it could be stolen so that a black box engagement for an adversary becomes a white box engagement. You can read the code, find the bugs, exploit production. Also, in many organizations, there's an internal culture of sharing and collaboration. And it's often the case that source code is available to all the developers in an organization. So the developers will be split into teams, but often every team can read everyone else's code for knowledge sharing, collaboration, and interoperation. So if you take one developer's workstation, you might have the access you need to take all the code. So the supply chain, as Pat alluded to, the supply chain is really, really interesting and messy right now. So there's the free open source supply chain. You look at things like NPM, you look at Ruby gems, and there's a whole bunch of awfulness being put out into that space. And there's also a whole bunch of takeovers happening in that space. So there was ESLint a few months ago, and just this week, Bootstrap SaaS was mentioned by Snyk as having been compromised. So I'm not saying that exploiting an open source developer is the best way to get yourself into this ecosystem. You know, in the case of ESLint, it wasn't exploitation, it was social engineering. But takeovers of popular open source packages get you into a whole lot of interesting places. And what about the non-free supply chain? We look at things like CCleaner, Azus, and other such incidents. We've got cases where organizations are compromised and malicious updates are pushed out to genuine customers. And a really good place to do this sort of attack from, in my opinion, would be the developer's workstation. So 2019, 2018, 2017, all years of DevOps. You know, DevOps is pretty banging right now. And so it's the case that in many places, your software developers, they are your sysadmins, and they are people maintaining, troubleshooting, and whatnot with infrastructure. So again, I'm not a pen tester, but on a developer's workstation, I think these 3 files would be pretty cool to have. You know, your bash history gives you the mud map of the network. Where do the developers connect to? Where do they SSH to? Take the SSH key, take the AWS credentials. I think you're having a pretty good day. And finally, the security team. You know, myself, I review software source code. My machine, I think, is a pretty cool place to be as well. If you take over a machine of a software developer, that's all well and good. But someone who works in security who's also using the same tools, on our workstations, there are things like client reports. We might take our machine from client to client without necessarily scrubbing it in between. We may be giving attackers free ride into our customers' networks. And I think it'd be really cool to kind of piggyback on a pen tester's machine and go into an environment. They start doing hacking, you do hacking with them, and then the blue team goes, oh, don't worry, there's a pen test going on. So we've talked about what do I mean when I say software development software, and we've talked about why I think the users of this software, a couple of reasons why I think they're pretty interesting targets. I really want to kind of peel back the layers now on a few vulnerabilities I found a few years ago, because I think they're pretty cool. So the first one I'd like to talk about is Ruby Version Manager, or RVM. So Ruby Version Manager is one of those helper tools from the slide I showed earlier. What it does is, either as the developer of Ruby code or the user of Ruby code, it helps you juggle and manage all the different Rubies you need on your machine. You know, I've just picked 3 popular Ruby-based pen testing tools, and they all want different versions of Ruby. So RVM helps you install all these different versions to your home directory and switch between them when you need to. This is kind of funny and kind of cute, I think. The Metasploit Development Environment Setup Guide suggests that you install RVM to help you juggle your Rubies while hacking on Metasploit. And this is the reason why I used to have RVM on my machine. So how does it work? Once you've installed RVM, it pokes itself into your .profile file, which means that every single shell you open, RVM is there. It's in the background waiting to help you out. When you CD into a directory that is a Ruby project, like Metasploit Framework, RVM is kind of like Clippy, and it pokes its head out and goes, hey, looks like you're doing some Ruby development. Would you like to install Ruby version whatever? And so you install it. And from then on, whenever you CD into the Metasploit directory, your path changes. And the Ruby that your system will choose to run switches behind the scenes automatically. So I thought for a while, that's pretty useful. That's also pretty interesting. I wonder how it achieves that. How does RVM switch my Rubies on the fly for me? And then I didn't look into it. Until one day I was doing some shell scripting. And I had turned on the set-x option in my shell. So the set-x option is a debug option in Bash or Bourne shell that basically prints out every time something happens, it'll print out what happened. So it's really good for keeping an eye on what your shell scripts are doing and helping you debug your scripts. So then I did a CD, and this happened. And like pages upon pages of debug output popped out, all to do with RVM. So at first I was like this, and then I was like this. I realized that RVM was hooking CD. And whenever I ran CD, RVM would be like, oh, is there something that I can do to help you here? The place you're CDing to, does it look like a Ruby project? If it does, can I help you stitch up your environment to support you running it? So I wanted to dig in and find out how was Ruby Version Manager checking to see if what I was CDing into was a Ruby directory, and all the parsing of files that I knew I would have to do to help me out. So I grepped through the code for .ruby version, which is one of the such files in a Ruby project that specifies which version of Ruby RVM should switch to. Then I dug into the RVM RC project file, which looked kind of like this. And there were all these chunks of code that pertained to different Ruby version type files. So I thought I was on the right track. And I saw this red highlighted bit of code, which is to do with environment variables. And I thought, if I can drop a file in a directory and someone CDs into it, and then I can set their environment arbitrarily, I'm having a pretty good day. So to make sure I was on the right track, I used the age-old technique of debug by Printf, which is where you just like echo, yes, I'm in the function you thought I was in. This is what the value of this variable is. This is what it's basically how to debug when you don't know how to use a debugger, like me. And I followed the bouncing ball to where these environment variable things were being handled, and ended up here. Down the bottom of the screen, you'll see export something equals something. And this kind of confirmed to me that I could put arbitrary stuff into these versions files and put arbitrary stuff into people's environments. So that was vulnerability number 1. And then I thought, that something equals something is wrapped in an eval. So if I can get shell meta characters into either the key or the value, there's another vulnerability. You can just straight up run stuff inside that eval. And I saw that there was code to sanitize the user supplied string. And if it saw backticks or dollar bracket, it would drop a backslash in front to sanitize it. For anyone who's tried to bypass SQL injection filters, they might recognize this as, you just bring your own backslash to the party and the two backslashes cancel each other out. So let's have a look at what this actually looks like when you try both of these two things. So this is a fresh Docker container just with RVM, an old version of RVM installed in it. So if we make a directory called POC, cd into it, and then get our versions.conf, and we just do ruby equals system, otherwise things just kind of break, env foo equals bar. So based on my understanding of the code and following the bouncing ball, this should set the foo environment variable to bar. Cd into the directory, echo $foo. So we've got this primitive. We've got this primitive that lets us put arbitrary stuff into someone's environment if they cd into our directory. When you control someone's environment, there's a few options. I know of a few. I'm sure there's many more. There's a few options to going from that to arbitrary code execution. And the one that I chose to exploit, because in this case my victim would be running a shell, is to exploit the PS1 environment variable. The PS1 environment variable normally shows or specifies what the person's shell prompt looks like. So if I set their PS1 to be the old PS1, and then put some shell injection stuff in it, we saw that RVM will drop a backslash in front of that shell injection. But the cool thing is that when PS1 gets evaluated by the shell to show that status line, it will actually expand it once more, because we actually do want to be able to put arbitrary shell stuff in our prompt so we can have all sorts of funny statuses come up in our shell prompt. So based on that, if I cd into this directory, we can run arbitrary commands every time someone presses enter, and I think that's kind of cool. The second bug was, we'll go back to foo equals bar. So we'll get rid of that one, echo foo. The second bug was to do with that escaping behavior, because if we put $ID in the foo environment variable, the victim will have their foo environment variable set to bar $ID. Because RVM was sanitizing our string and putting a backslash in front of that shell injection. If we put our own backslash in front of it, and RVM puts another one, the two backslashes cancel each other out, and we get our shell injection because the 2 backslashes, the first escapes the second. So if we just set that to 1 backslash, cd into it, $foo, we've got shell injection again, and the victim doesn't even need to do that echo. If we just go and spit the output of ID to standard error, we'll see that it just runs automatically as soon as the user CDs into that directory. So a quick recap. It started off with a bit of a hunch and a bit of a hypothesis. Started off with the hunch of, I wonder how, being that kitty cat, I wonder how RVM does this under the hood. I should probably understand this. It's in my tool chain. It's in my shell 24/7. I should probably think about what it's doing. And then with the set -x, it was, oh wow, that's a lot of output. So then you just follow the bouncing ball through the code. You put those little print statements in until you get to the place where interesting stuff is happening with your input. So you do interesting stuff with that input, and then you go to the pub. So Visual Studio Code. So we'll put RVM aside for a moment. Visual Studio Code is a really, really nice free IDE from Microsoft. It scored really, 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 really high in last year's Stack Overflow developer survey as being an IDE of choice. And it gives you all the kind of the nice things an IDE gives you. It gives you syntax coloring, gives you that tree view so you can see all your files, has nice Git integration, the whole 9 yards. It's a really nice place to be when you're reading or writing codes, and it's free. I was really, really bored one day and reading the documentation for VS Code. And in the documentation, I saw that you could have something called Workspace Settings. So the Workspace Settings, it's a file that gets committed to a source code repository, to a project, so that all the developers can share the same configuration. So we all have the same color, the same font. We all have really, really important things like the same tab width, so we all have the same indentation. It lets us sync up on those settings so that we have consistent source code as an output. I recalled having heard about, because this is a little bit before my time, I was in high school at the time, I recalled hearing about a Vim vulnerability in something called mode lines. And mode lines were Vim's way of having settings declared in a file, so every time you edited the file, you would have the same settings as everyone else. And there was a vulnerability in it in which you could execute arbitrary commands. This was really cool because a lot of people used to write and read email with Vim. And so you could send someone an email, they go to reply, boom, code execution. I thought, if Vim had a vulnerability in its handling of these settings, I wonder what Visual Studio Code is doing. So I read through the list of configuration options that could be set by this settings.json file. And one was pretty interesting. I could configure the path to Git, to the binary Git, which I know VS Code has really nice integration with. So I could put a settings file in my project and other people download it, they open it up in VS Code, and I can tell their VS Code where on the file system to find Git. This might be interesting. So I started by setting the path to ZZZZ, and then ran code under strace. And strace is a Linux application that lets you debug and monitor all the syscalls that a process is making into the kernel, including running external programs. So I could see that, yes, indeed, my VS Code was trying to run something called ZZZZ. I thought, this is pretty cool. I'll probably just put a whole bunch of shell commands in that Git path, and then people will end up running Bitcoin miners when they edit my code. But it wasn't to be that easy. And this might seem like a mundane point, but I think it's super important. If I put multiple commands in that Git path, they weren't run as a shell command. Like, my computer was actually looking for a binary called ZZZZ space XXXX semicolon YYYY. So if I had just dropped in the git.path, touch/temp/win, opened up VS Code and nothing happened, I might have gone, drats, I'm going to the pub. Turns out there's 2 different ways that a process on Linux will tend to start external processes. There's the exec family of functions, and there's system. So exec is really, really nicely well formed. It's a bit more verbose when you go to use it, because when you use exec as a developer, you need to say, this is the binary I want to run, and this is the array of arguments it should take, and I know what I'm doing, do it. System is like, YOLO swag, here's a command line, shell, you figure it out. It just like throws it over the fence. So the system command is where you actually get these shell injection vulnerabilities. With exec, you don't get that flexibility as an attacker. So it was really important to see this and see that I had an exec primitive, so I knew what I was working with. The next test I did was setting the git.path to true, which according to the man page does nothing successfully. And I saw that there were multiple commands happening. There was true -- version, true rev parse, true status, so on and so forth. When I set the git path to false, which is a binary that does nothing unsuccessfully, it only did false -- version, and then like killed the chain. VS Code was thinking, well, I tried to run git and I got back a bad exit code. Git's probably broken. I'm not going to try and keep on running it. That was also really important to know. The last little test I did was I wrote a small shell script that whenever it was run would log how it was run. It would log the command that was used to execute it, the arguments it got, and the directory that the process that invoked it was sitting in at the time as its current working directory. And interestingly, the first instance of Git being run was done from wherever the person was sitting when they wrote code passed to the repository on the command line. But the second one, the rev parse, happened from within the project. And this was a really important fact that I think without it, I would have had trouble exploiting the issue. So this is what I knew I was working with. VS Code was going to run whatever I told it the path to Git was as a binary -- version. And if that command failed, code was going to give up and be like, psh, not going to happen. But if that command succeeded, it would cd behind the scenes into the workspace directory and then do the path to Git, rev parse, and so on and so forth. I had two goals. I wanted to not break the chain until I had done something naughty. So you've got to keep this chain going until you can get arbitrary command execution. So what I did was I played around and found out when you did sh -- version, sh would exit with a bad error code, but bash -- version would return 0, which is all good. Same with Python, same with PHP. So I decided to go with bash, being on almost all boxes, I think. So bash -- version will succeed. And then code will cd into the workspace and then do bash rev parse. But what if I had put a malicious shell script in the project called rev parse? Would bash run it? Maybe. So let's have a quick look. So again, this is just a Docker container running an old version of VS Code. Make our POC directory, make our VS Code directory, which is where this workspace settings file has to go. Settings.json. So we'll set the git.path to be bash. And then we'll create our rev parse file. And we'll give it a shebang line because I'm pedantic. Run xcalc and pwned as the user's ID to temp win. And then what we'll do is we'll just do exit 1 so that Visual Studio Code, when it runs this command, it will just give up and not run the rest of them and it'll kill the chain. So we got the git.path set to bash, and the malicious payload is just going to pop calc and then just edit a text file. That temp win file does not exist. So if we run code on the current directory, or if we cd out of it, and run code against the POC directory, we'll get the same behavior because of that very convenient CD that code does for us. So Visual Studio Code opens up, and we don't get a calc. What did I? Oh, setting. Thank you. Didn't make enough sacrifices. Aha, I'm in the wrong directory now. So move the setting to settings. Thank you very much, Glenn. Try again. So we'll make sure that file still doesn't exist. Run code against the POC directory. And there's our calculator. And there we go. Arbitrary code execution as the person running Vim.
Proving once again that the best single step you can do to secure yourself against bad hackers is to remove calculator applications from all your machines.
See, now that they've actually open sourced calc, so hopefully someone will fix the vulnerabilities soon.
Or someone can use calc to pop calc.
That'd be brilliant. See, now we can actually get position-independent calc shellcode. Now we've got the source code and don't need to run the command anymore. Quick recap. Starts off with a bit of a hunch. Reading the documentation because you're very, very bored and going, didn't Vim have a problem with this sort of behavior? It's surely a lot of responsibility and a lot of attack surface when an editor reads a settings file out of a source code repository. So then you dig in and you use strace to make sure it's actually running the commands as you're telling it to, and then you do the true or false thing, and you do the shell script thing, and you end up with a pretty reliable POC where you swap out Visual Studio Code's idea of Git for bash, and you give it a nice little revparse shell script to run. So a much better bug than the one that I found. It didn't exist for too long, but Code Colorist found it in versions 1.19.1 through 1.19.2 or something. No, 1.19.0 through 1.19.2. It was like only a few weeks, I think, in which Visual Studio Code was shipping with certain parts of its Electron-based architecture running in debug mode, which is Ghidra. VS Code did it first. And when you run Electron apps in a debug mode, it opens up this local host-only debugging port, although I think Electron has also mitigated this sort of thing now with some magic cookie stuff. Code Colorist figured out that if you can talk to someone's local host port 9333, at the other end of it, there's a Chrome debugger. And when you can talk to the Chrome debugger, you can just run arbitrary JavaScript that can actually interface with the file system and do awful things. And built out a full DNS rebinding-based proof of concept to get, drive-by code execution on VS Code. So that's a really cool bug, way better than my trash bug. Putting it all together. So putting together the RVM bug and the Visual Studio Code bug. We've been developing locally, and we can see we've got something that might be promising. But what might it look like in a bit more of a real-world scenario? So maybe it's the case that you can convince someone to download some of your source code, like, hey dude, you should git clone this, it's really interesting. When the victim then git clones it and CDs into it, if they've got a vulnerable version of RVM installed, there's your first opportunity for arbitrary code execution. If they use Visual Studio Code and it's out of date, there's your second. So this is the party trick demo. Hopefully it works. It's a little bit fragile. So we've got two Docker containers here. On the left-hand side, we're looking at the victim. On the right-hand side, we've got the attacker with 3 old-school Netcat reverse shell listeners and 1 web server. So the attacker sends an email to victim. Hey, you should totally git clone this. It's not malicious at all. And the victim goes, okay. Thinking, git clone's pretty safe, right? And we get our first reverse shell. So this is actually an old version of Git. This bug's been patched, and it's not my bug. It's a bug that if you do a git clone recursive, to download all the submodules. That's terrible highlighting. There we go. Do a git clone recursive, which will download all the git submodules along with the main repository. Really nice bug, and you can get like shell injection. It's really cool. So the attackers got their first reverse shell. So the victim has git cloned something. They go, all right, let's have a look at what's inside. CD, totally not malicious. Second shell. Thirdly, and finally, the victim thinks, I'm going to use code to actually have a look at this project because someone clearly wanted me to read what was in it. Open up Visual Studio Code, and in the background, we get our third shell. Thank you. So I'm actually running super ahead of time, which is awesome. All my practice runs of this were way longer. So now I'm freaking out. I don't know what I forgot to say.
This is not what we discussed, Justin.
No, it's not. I was going to go right up to the end of the session so that I didn't have to answer questions.
Well, I got one for you. Can't you just fish the dev?
Got
You're not finished yet. Oh, you got more?
No, I've got like 5 minutes more.
Okay.
Sorry, I do have a bit more, but I am running well ahead. I was thinking I'd have to like blast through this. Little bit more. Is this a risk? You know, is this actually a problem? I don't really know. I don't do operational hacking. I can't imagine that the bugs that I used earlier would be that useful. Like, they're pretty high interaction. But maybe. You know, we saw a case last year of espionage against the, I think it was like engineering and industrial design vertical, in which malicious AutoCAD files were being sent to victims, and when you open them up, they have like their own version of macros, and away you go. So if people were flinging AutoCAD files around to own each other, maybe flinging code repositories around isn't that far-fetched. But yes, Pat, I still think that phishing is probably the way to go.
Fish dev or offer them $200 to take over their
Yeah.
project they don't care about anymore.
A little bit more? I was acknowledging that you said that yes, phishing will still work. Sorry, dude.
He's doing this deliberately.
Not at all. A few more thoughts. See, this back and forth is what's going to fill the time up, so therefore... patching. So this is a bit of a no-brainer, I hope, but we need to be patching our software. Interestingly, RVM doesn't have an auto-updater. So if you've got like a crusty old Kali box and you had RVM installed to do some Metasploit hacking, maybe you've got some RVMs that need to be updated. But patching is obviously a bit of a no-brainer. Jeremiah Grossman tweeted this, and I really liked it. Without going to like exploit zero-day fuddy, if what's standing between us and owned catastrophically is hoping that there's no bugs in our software, hoping we're up to date, hope's not that much of a strategy. So we need to think about how can we protect ourselves as security professionals using these tools, and how can we protect developers who are using these tools as well. One idea I have, it's not fully baked, but I think the future of end-user computing is certainly some form of containerization, some form of sandboxing, some form of isolation. I think getting there for developer tooling is going to be hard. I think, you know, downloading your IDE out of the Windows App Store and being able to do the things you need to do with an IDE without it having access to your entire file system and being able to run arbitrary processes, they don't really kind of go together that well. So I'm looking forward to seeing what comes out from operating system vendors and IDE vendors to keep these very powerful tools safe. Or on the other hand, we're just going to go, well, an IDE is meant to write and run arbitrary code. It's too hard of a problem. Fair enough. So what I do is I run Visual Studio Code inside Docker on my workstation because I'm a crazy person. So like all the demos today were done inside Docker. You can make a lot of tools. I run Burp Suite inside Docker. I run my browsers inside Docker, so on and so forth. And what you can do is you can choose to only expose to an instance of VS Code what you're working on. You don't get my SSH keys. You don't get all the other projects I'm working on. Just this one thing that I want to work on today. So Jesse Frizzell has some really good resources on Dockerizing arbitrary applications, and you should definitely check them out. Something I'm very aware of is that Docker is certainly no silver bullet, and it's also not technically a sandbox. We saw a few months ago the run C bug was a really, really nice Docker escape. It did require some admin interaction. Go back a little bit longer, Dirty Cow was a kernel bug that was very heavily advertised as being a Docker escape. And furthermore, if you're going to run graphical applications inside Docker on your Linux machine, you need to expose X11 to the container. And Metalstorm has this awesome video that you should definitely check out, all about Unix party tricks. And in there, he goes through what sort of stuff can you do as, for example, a compromised Docker container if you can talk to a user's X daemon. Turns out a lot of really uncomforting things. So just putting your IDE and your tools in a Docker container is not silver bullet security. I think it's getting us in the right sort of direction, and I think containerization and sandboxing of end-user software is the way that we will probably go. You look at Apple, they had the opportunity with iOS to go ground up new operating system, and it was just like sandbox by default. Applications run in jails and sandboxes, period. And I think if we had the opportunity to redo incumbent operating systems again, that's the sort of way we'd have to go. So as well as that, there's the standard stuff. Things like monitoring and detection. Are you doing monitoring on developer machines? This is maybe a no-brainer, but it's also quite tricky. Developers have this really interesting habit of bringing their own machine to work, using MacBooks, and so you need some sort of policy, you need some sort of way to get monitoring on developer workstations. I believe that developer workstations are going to become the new domain administrator type of compromise, where once you get a developer, the whole world is your oyster in an organization. So we need to be looking after these machines and treating them like gold. What about two-factor auth? Do you have two-factor auth on your source code repositories? Do you have two-factor auth when configuring build servers? Do you have two-factor auth on AWS? Like on the web interface is one thing, but on the CLI, do your developers have a habit of having AWS credentials files that don't require two-factor auth through, as I understand it, you can force the developer's token to have to assume a role and be challenged for MFA. They can't do anything else. It's kind of like sudo. We kind of did something right there. But if your developer AWS credentials go missing, do you have two-factor auth on that API? And so have a discussion. Have a discussion with the security team, application security, the blue team, GRC, and the developers. And aim to make it a really collaborative discussion. Don't go into it thinking we're going to walk out with a list of things we need to take off of our developers. They've got a really hard job to do, and if they think they're walking into an ambush, they're not going to play ball. But instead, just look to understand. If your machines were compromised, what's the worst that could happen? Ask your developers, we know you're not going to do this, but if you turned rogue tomorrow, what sort of damage could you do just with your laptop? Where would you move from? Where would you move to? How would you do it? We need to understand so we can put monitoring, so that we can put strong authentication on those channels. And lastly, this is a bit of a crazy one, but what about some sort of red team engagement where you would give the red teamers an assist and just drop them straight onto a developer workstation or onto the clone of a developer workstation and ask them, how far can you go? If you're on a development machine, where can you get to? And if your reaction to this is a bit like, ugh, I don't want a contractor or a red teamer starting from there, they're going to destroy us. That might be all you need to know about how important these workstations are. So thank you for coming to my TED Talk. I've got a few links. Follow me on Twitch to watch me do dumb stuff live. The slides will be up on GitHub today. And if you want some more VM vulnerabilities, they're in my advisories repo. Now I'm done.
Okay. Justin Stephen, who is actually inside a Docker container. He just containerized the whole thing. And if that's the metal talk that I'm thinking of, is that the one where he could only use user accounts and try to get persistence on Linux boxes that he don't?
No, but I have to check that out. That sounds
that
awesome.
one was amazing because he was doing red team engagements where he wasn't allowed to privesc to root on their production Unix, so he had to come up with all these other party tricks. Basically, metal and Unix party tricks are always sobering, let's put it that way. And it is very interesting what you say, especially as we move to DevSecOps, zero trust, which is the latest buzzword.
Yep.
The idea that developer machines are the new AD admins. I think that's a really, I'm totally going to steal that line.
Do it.
That makes a lot of sense. Everyone give it up again for Justin Stevens.
Thank you.